This video is on how to divide with radicals and how to rationalize the denominator. So we've talked about the quotient rule before, and when we talked about it last, we talked about if there is a fraction inside the radical, so for example 36 over 9, that we can separate this into the square root of 36 over the square root of 9 to get 6/3, which is 2. Well, today we are also going to see that we can join numerator and denominators if the index is the same. So what that means is, in example 1, it says simplify each quotient and write each answer in simplest radical form. So instead of simplifying the square root of 48 divided by the square root of 3, instead we can put them together, the quotient rule says, and then we can divide or simplify the fraction 48/3. And 48 divided by 3 is 16. And then we would do the square root of 16, which is 4. Now, the quotient rule says that we can, because the index here are both 2's, that we can put them together and write it as 48/3 as one fraction. But we can also do this problem as the square root of 48 and the square root of 3 separate, and simplify the square root of 48 using the methods we learned in class. So I can write that as 16 square root of 16 times the square root of 3. So we would get 4 radical 3 when we simplify that. And feel free to pause the video if you need to take a little bit more longer to simplify your radicals, because remember I taught you 2 different ways to simplify radicals. This is considered method 1 that I just did, but there you could also make a factor tree. So instead of radical 48, we can write that as 4 radical 3. And then when you have the same thing over the same thing, that makes 1. So we're just left with 4 times 1, which is just 4. So the point is, we can simplify them each separately, if possible, or we can try joining them together, and 48 divided by 3 was just 16, and the square root of 16 was 4. So that's what the quotient rule tells us that we can do. So let's try example 2. So we can try to simplify each radical separately. So we wouldn't be able to do anything with the square root of 21, but we could, since this index is 2, we could simplify the numerator if we'd like. But instead of doing that, I know the quotient rule says that we can put them together as one radical, and we can do that because both of these index are both 2. So then now I'm going to use a chapter that we've talked about before, where we simplify fractions. So 21 divided by 3 is 7, and then we subtract the exponents here, so 3 minus 1 is 2. And now that I've joined them, now I'm going to simplify the square root of 7x squared. So the square root of 7 is already simplified, because if we try to make a factor tree, we don't have any of the same number. So the square root of 7 stays there. But the index 2 goes into 2 once, with none left inside. So we're going to have an x here on the outside, because it went in once, so we're going to have just x to the first power. And that would be our answer. Alright, in this problem here, we cannot join them, because the quotient rule says that we can join them if their index are the same. So in this problem here, this is not the square root of 14, so we cannot join them. We also cannot do this. We can't say, oh, 7 goes into 28 4 times, and 7 goes into 14 twice, because this is not 28 over 14. This is the square root of 28, which is a little bit higher than it's about 5 point something. So we cannot simplify something in a radical with something that is not. So the only thing left to do is to simplify our radical 28. So see if it can be simplified. So use method 1 or method 2. So I can rewrite square root of 28 as a square root of 4 times the square root of 7. And the square root of 4 is 2. And then the square root of 7 is completely simplified. So now I'm going to rewrite the square root of 28 as 2 rad 7 over 14. Now, because if this problem looked like this, we could not simplify the 2 and the 14. But because this is being multiplied to the square root of 7 here, when something's right in front of it, it means multiply. So in this case, we can't. But in this problem here, the 2 and the 14, we could simplify. So 2/14 simplifies, has a common factor of 2, it simplifies to 1/7. So we can write this as 1/7. Okay, so that would be acceptable, but just like when we have x, we don't have to write a 1 in front of it, because it's implied. Well, if we have a radical 7 right here, it's implied we have 1 radical 7. So remember, when something's in front of the radical, it means multiply. So by having this 1 here, 1 times radical 7 is just radical 7. So we don't need a 1 in front of a radical. So this would be the best one, but this is not wrong to put a 1 there. Okay, so again, we can simplify each radical in the problem individually, or we could say, well, look at that. The index is 3 in this problem. So we can rewrite this as 1 radical. And the nice thing about doing that, and remember the 7 just means times, so it's just out in the front being multiplied to this radical here. And the nice thing about joining these here is now we can use a previous chapter and simplify this rational expression here. So we have 16 divided by 2, which is 8. And then our rule here is to subtract the exponent, so 5 minus 1 is 4. And now to simplify this, remember this was a cube root. So this 7 is going to get brought down. So this is asking us what the cube root of 8 is. So what times itself 3 times is 8, and that would be 2. And then 3 goes into 4 once, so you're going to have an x out here. And there will be 1 left inside. So putting that together, we would have 7 times 2x is 14x. Rad x. And of course we can't forget this was a cube root here. Can't forget that. The index won't change. If it's a 3, we gotta have our cube root here, because then it changes things. So now that looks much better. That's our final answer. Okay, in this problem I noticed that the index are both 4, so that means we could join it and simplify it all together first before we do anything with the radical. So let's write that a little bit smaller there. Okay, so we have the 64, and then our rule, when the bases are the same and we're dividing, we subtract the exponent. So 5 minus, we just have 1a, so that's 4. And then we have 1 minus negative 3 here. That also makes 4. Okay, so now to simplify this, we have to think of what multiplies 4 times to make 64 a to the 4th b to the 4th. So let's start with the 64. So I'm going to go ahead in this method with this problem, because this index is high, I'm going to make a factor tree. So I know 8 times 8 makes 64. And then I know 2 times 4 is 8. So this is method 2 to simplify a radical. And then I circle it once it's prime. And all these numbers I just circled should multiply to make 64. So then I gave you guys an analogy, or a way to think about this, like the radical is the jail. And to escape the jail, we need a group of 4 of the same number. So 1, 2, 3, 4, they escape, but only one survives, only one of those 2s. And then here we have 1, 2, but we don't have enough for 4. So these 2s here are stuck inside. So if I have a 2 and a 2 inside, that's the same thing as 4. Okay, now onto the variables. 4 goes in a 4 once. So we're going to have just an a on the outside of the radical. And then 4 goes into this 4 once as well. So we're just going to have a b on the outside. So this is our final answer.